Question 7, part 1. We're given that y is equal to x times the square root of x squared plus 1, and we need to show that dy by dx is equal to this part here, where a, b, and p are positive constants. So to differentiate y with respect to x, we're going to need to use the product rule, which I've written out on the top right here in red. So if u and v are both functions of x, then the derivative of u times v is going to be equal to the derivative of u times v plus u times the derivative of v. So for our problem then, if we take our u of x is equal to x and our v of x is equal to the square root of x squared plus 1, then we can go about and find the derivative of y with respect to x. So what we get then is we have dy by dx. That's going to be equal to the derivative of x, which is just 1, times x squared plus 1 all square rooted. So we're just going to end up with the square root of x squared plus 1 plus our u, which was x, times the derivative of x squared plus 1 all square rooted. So I'll just write out up on the top right here, we'll write the derivative with respect to x of the square root of x squared plus 1 as x squared plus 1 to the power of 1 over 2. So then we can just use the chain rule here. So if we multiply the whole thing by half, so multiply by the indice, we're going to get 1 over 2 times x squared plus 1. Take 1 off the power, it's negative a half, and then times by the derivative of the inside. So the derivative of x squared plus 1 is just 2x. So we multiply that by 2x. So coming back to our problem then, we're going to have x times 1 over 2 times x squared plus 1 to the power of negative 1 over 2 times 2x. So we'll start simplifying this down a bit. So we're going to get the square root of x squared plus 1 plus, well, these 2's will cancel here, and then x times x is x squared, and then I'll write this x squared plus 1 to the negative a half as 1 over the square root of x squared plus 1. So now if we multiply this term here, the square root of x squared plus 1 by the square root of x squared plus 1 over the square root of x squared plus 1, then we can write these two terms over a common denominator. So we get then, well, the square root of x squared plus 1 times the square root of x squared plus 1 is just x squared plus 1. And then we get our plus x squared, and that's going to be all over the square root of x squared plus 1. And that equals 2x squared plus 1 over, and I'll write the x squared plus 1 as x squared plus 1 to the power of a half. So it's in the same form as what we had in the question. And that's our answer for part 1. So that means our A would be equal to 2, our B is equal to 1, and P is equal to 1 over 2. So that's part 1. For part 2, we need to explain why the graph of y has no stationary points. So if we're going to have stationary points on our graph, we need the derivative dy by dx equal to 0. So we'll note that down. That means then that the numerator part here, this 2x squared plus 1, must equal 0 if our derivative is going to equal 0. So that implies then that 2x squared plus 1 equals 0. So that means we would have to have 2x squared equal to negative 1, but that is obviously not possible. We can't have something times x squared, a positive number, times x squared equal to 1. So we can just note, but 2x squared does not equal 1 for any real value of x. You could just write any value of x as well. Okay, I'll just make it clear though that we're dealing with real numbers. So we say, but 2x squared does not equal 1 for any real value of x. Okay, and that is question 7.